Howdy ho, Mouseketeers. Today we're going to be jumping off into Unit 8 and we're going to be talking about factoring. This is a huge unit, so I really want you to get the hang of this from the get-go. We're going to start out with factoring. The greatest common factor is our GCF. So if something's asking you for the GCF, it's asking you for the greatest common factor. And we talked about factors back in Unit 2, a number or variable that can multiply by another number to get a product. And let's just start out with a little bit of warm-up here from where we were back in Unit 2. So if you distribute what's in front of the parentheses to everything in the parentheses, so we're going to multiply 2 times W is 2W, and 2 times 1 is 2. So that means the GCF was 2 for this particular problem. That was what was in front of the parentheses that got distributed that made our polynomial. So again, multiply the 3x times x squared minus 4. The 3x is distributed to everything in the parentheses. This is back when y'all were learning your exponent rules. So x times x squared, you use product rule, and you're going to get x cubed. Then 3 times negative 4 is negative 12, and then you have your x. So the greatest common factor was 3x. That is what was multiplied in front of the parentheses to give you your polynomial. Now let's do the same thing here. We're going to distribute and have 3 times negative 2 is negative 6. Then x squared and x is x cubed. Y cubed is going to tag along there because there's nothing for it to multiply to. Now negative 4 times negative 2 is a positive 8. Then you have x cubed y to the 4th power. So your greatest common factor was negative 2x squared y cubed. So this was your greatest common factor. So we're going to use that idea. Here's the greatest common factor definition for you. The highest number that will divide evenly into 2 or more numbers, also known as your GCF. Factoring. Let's use that idea to think about what the goal is. The goal is to figure out what factors multiplied to get this polynomial. What exactly was out in front of the parentheses that we distributed to make the polynomial? What did we distribute? What was in front of the parentheses? So you're thinking about undoing the polynomial. So we started out in Unit 2 with our factors. We distributed and multiplied. Distribute to get the polynomial. Now we're going to be working our way backwards, kind of undoing the distribution. And that is where factoring is very, very helpful. And we're going to learn different methods for factoring, but for today we're just going to take a baby step and talk about greatest common factor. So 16, 32, and 40, if you think about the greatest common factor, well, there's a lot of factors of 40. But let's go with the greatest factor. So let's do 8 and 2 for 16. 32 is 8 times 4, and 40 is 8 times 5. So if you notice, all of these numbers have a factor of 8 that's common. And that's as high as we go, because 2 will not divide into 5, and 4 does not divide into 5. So your GCF for these 3 numbers is 8. That's the greatest common factor. It's the highest number multiplied into all 3 numbers. So x's and y's. The same idea applies to variables. And actually, I think the variables are easier because you're not having to think what divides or what multiplies to make what. But let's hear. I'm going to draw out 3 x's and a y because that's x cubed y. Now I have 4 x's and I have 2 x's. So literally, I have exploded out my terms here and I have drawn what I'm looking at. So my GCF, the greatest common thing that I can find, let's look at the x's. It's going to be x squared. I can't go any higher than that because that's all that this term has to give. It can't give x cubed because there's not 3 x's. And it can't give x to the 4th because there's not 4 x's. So the highest you can go is x squared. So if I take out an x squared and an x squared, there's my GCF, x squared. Now your leftover business here, it is important, and we're going to talk about that next because we use those. So going to the back page, here's your steps. You're going to determine the GCF. Then you're going to put that out in front of the parentheses so you can use it and divide each term by the GCF. And then you're going to rewrite the product. And it's going to look like this. Actually, let me use another color here. our GCF is going to be out in front of the parentheses, and then all of your leftover business, the leftover jazz, is going to be in the parentheses so that we can think about undoing our distribution. So that's what your answer is going to look like. Looking at this, we have 1 term, 2 terms, and 3 terms. There are 3 terms in this problem here. And we're going to think about what can we take out of each term that is the maximum factor. So looking at the 3, the 6, and the 9. 3, we have 3 and 1. 6, we have 3 and 2. And 9, we have 3 and 3. So I see a common 3. So I'm going to get my GCF going, my greatest common factor. I'm going to have a 3 coefficient here. Now let me look at the A's. And since this is our first example, I'm going to draw out all these letters so you can see where they're coming from. A, and A give me A cubed. Now here I have 6 A's. And on the last term, I have 4 A's. So what's the common greatest number of A's that I can divide out of each of these terms? Well, I can take out 3 A's, 3 A's, and 3 A's, so A cubed is going to be attached to my GCF. Now, before I go any further, I'm going to look at my leftovers. I have a leftover 1, 2, 3. I've got A cubed and a little lonely A back there. And notice all the A's have been factored out of this first term, so they're all circled and taken away. So let me check out my B's. I've got B squared, B cubed, and another B squared. So the maximum number of B's that can be factored out into my GCF is going to be B squared. So let me check out my leftover B's. No leftover B's here, 1 leftover B there, and then none here. So now the last one is C. C squared and another C squared. So in my GCF, I can only take out 1 C because that's the maximum C's that the first term has. It can't give any more than that. So you can only factor out 1 C for your GCF. This, my friends, is the greatest common factor. This is going to go in front of your parentheses. That is what you use to distribute with. So we have 3A squared, A cubed, B squared, and a C. 3A cubed, B squared. Now let's get our parentheses set up, and we're going to collect all of our leftover stuff that was factored out. So looking at the first term, this is term 1. All of this business here. If you take 3A cubed, B squared, C, and divide it by your GCF, all you're left with is a 1. Everything else was factored out and came out with the greatest common factor. So the only thing left behind is that 1 right there. So we're going to use it to hold the spot for our first term. Now you have a plus sign. So plus, now 6 divided by 3 is 2. Notice we had a leftover 2. A to the 6, factoring out A cubed, leaves you with 3 A's. B cubed, factoring out B squared, leaves you with 1 B. And then C squared, factoring out 1 C, leaves you with a C. So there is the second term. Now I'm going to put my minus sign here because I have a minus. 9 divided by 3 is 3. And then I'm down to 1A and 1C. Let's see if I can squeeze out. I should have made my parentheses bigger. 3AC, and that is your final Mamma Jamma answer right there. All of this business. Now, it's nice you can check your answer, because if you distribute your GCF to each term in the parentheses, you should end up right back where you started with. So it's a nice way to check your answer. Next one, GCF, the greatest common factor for 14 and 9. Well, can't use 2, can't use 3, can't use 7, and I can't use a 9. So I'm just going to say there's a 1, and I'm going to leave the 14 and 9 alone. They're going to stay put for right now. Now let me look at my x's. So I have x squared and y, and x with a y cubed. Maximum number of x's, the greatest number of x's that I can factor out here is x. That's going to leave me with 1x in my first term. Factoring out a greatest common factor of y's here, that leaves y squared in my second term. So my GCF is xy. Now let me look at my leftover stuff. I have a 14 and an x. I have a minus sign, and then I have my 9 and my y squared. And that is factoring out your greatest common factor. And you can check it by going backwards, using your exponent rules. and your distributive property, xy times 14x is 14x squared y, because you have two x's. 9y squared times xy is going to give you negative 9xy cubed. All right, let's look at the next one. Greatest common factor for m's and n's. I don't see any coefficients other than 1, so I'm going to leave my 10 and my 5 in place. Now, I can look at the m's, though. I have 3 m's and 2 n's in the first term, 2 m's and an n in the second term, and then 4 m's and 3 n's in the third term. So for my m's, the greatest common number of m's I can factor out is going to be 2. So I've got m squared as part of my GCF. Now looking at my n's, I'm going to take one n out and factor it away. That leaves me with n for the first term, no n's for the second term because we factored them out, and n squared for the third term. I am left with an m in the first term, no m's in the second term, and an m squared in the third term. So let's get my GCF out in front of my parentheses, m squared n. Now, let's start factoring. M cubed n, if you have 3 m's and you factor out 2 m's, you're left with 1 m. 2 n's, factoring out 1 n, you're left with 1 n. Now I have my minus 10 because I did not factor the 10. And the m's and the n's here with our second term, they were factored out, so they're gone. So it's just a minus 10 here. Now I have a plus 5, and then 4 m's, factoring out 2 m's, leave you with m squared. N cubed minus n is n squared. And there you go. If you notice, we're starting to get to where we can just subtract our exponents using those exponent rules. It's a nice little handy thing there. All right, going to the third one. See, we need a greatest common factor. 27 and 72. What will factor to give me 27? Well, I know 3 and 9. So let's see if 9 will fit into 72. That would be great. So yeah, it does. And then that is the greatest common factor here. So we have a 9. Now I have 2 x's and 5 y's. Here I have 3 x's and 2 y's. So the maximum number of x's that I can factor out is going to be 2. So I'm using x squared. Now the maximum number of y's I can factor out is 2. So I have a y squared. That is my greatest common factor. So I have 9x squared y squared out in front of the parentheses. Now let me look at what I factored out and what is left. So if I took a 27, I divided by 9, I'm left with 3. Now if I took x squared, taking out x squared, well, there's no x squareds. I factored them all away. Y to the 5th minus y squared leaves me with 5 minus 3, 5 minus 2 is 3, so y cubed. Now my minus sign. So here I have an 8, because 27 divided by 9 is 8. X cubed, factoring out 2 x's, leaves me with x right here. And then y squared minus y squared, well, there's no more y's then. So then you are done. Greatest common factor. Here we go. Let's look at the next one. We need a GCF. Let's see, 32, 32, and 40. So 32 will give you, let's see, 8 and 4, 8 and 4, and how about 8 and 5? So there's a maximum of 8 in my coefficients. Now, I am not drawing out 9 n's, so I'm going to switch over and use my exponent rules here. So if I have a maximum of 5 n's that I take out for my greatest common factor, so I have 8n to the 5th, and I have a negative 4 in my parentheses. Now, n to the 9 and n to the 5. 9 minus 5 is 4. So I have 4 n's left over. Now I have a plus sign. 32 divided by 8 is 4. 6 n's minus 5 n's is just 1 n. Last term, I've got my plus sign. 40 divided by 8 is 5. And then 5 minus 5, no n's. And you are done. There is your greatest common factor. Some backwards distribution there. Next one, let's look at 3 and 6. Well, that's not too bad. 3 and 1 and 3 and 2. So I have a greatest common factor of 3. Now, a squared and a cubed. So the most I can take is a squared. B and b squared, the most I can take is b. So this is my GCF. 3a squared b. And now let me look at what's left after I factor that out. So I'm going to have a negative. I have a -1, and then a squared b. Well, a squared b, all of my letters, all my variables were factored, so I'm just going to leave a -1 there. Now I've got a plus sign, because there's a little 1. Plus, and then see, I've got a 2, because 6 divided by 3 is 2. Cubed minus squared, so 3 minus 2 is going to leave me with 1a, and 2 minus 1 is going to leave me with 1b. And there you have it. All right, last one, 8 and 4. So 8 and 4, let's think, 4 and 1, and then 4 and 2. So my greatest common factor is going to be 4. Now let me look at the x's and the y's. I can't use y because there's no y in the second term. But the x's, though, I can take out x cubed. So here's my greatest common factor, 4x cubed. Now, if I factor 4x cubed out, what am I left with? Well, 8 divided by 4 is 2. And cubed, well, x's are gone. But I still have those y's, so I've got the y squared tagging along. Plus, now if I take the 1 and the x cubed and x cubed, it's just going to be a 1 placeholder. And you are finished. Greatest common factor.